Yeah, g'day guys. Now this was going to be a pretty conventional video. You buy a tool, you need to make some tooling to tool up the tool to be able to use it to make things. You know the plot. Now these are both boring heads for my milling machine, but the difference is kind of obvious. This one's small and this one's, but the difference is kind of obvious. This one is just a one-trick pony. It can only bore, whereas this one has got a bunch of other tricks up its sleeve. But before I can show you how it works, I'm going to need a boring bar for it. This is just your standard import boring bar. Not sure where I got it. I didn't pay much attention, and it seems this one has an imperial setting screw, but shown as metric. So it's a real pain in the neck to set it accurately, because you end up with some sort of a 2.54 of a millimeter per dash or something like that. You sort of end up having to try and put a clock on it, and it's hard to get it to fit properly, and yeah, it's just a pretty horrible tool to use. These boring bars which came with it initially had a terrible grind on them. So you can see that I've now ground them all with the Clarkson tool and cutter grinder to make sure I've actually got some positive back clearance in all directions so they don't rub. But enough about that one. This is pretty darn cool. On the end here, you've got a fast setting screw. Now the cool thing about this is it's got a spring-loaded detent inside it. If you just put the Allen key down that hole, you can't turn it, but you press it down till it clicks. And then you can do a quick setting of your rough diameter. And then the fine setting scale sets in 1/100ths of a millimeter of diameter. So once you've done a rough cut, it's very easy to then dial in a specific diameter. That's only going to happen once I've got a boring tool for it. It takes 25 millimeter boring equipment. Let's just double check it with a Scholblin 25 millimeter shank tool. Yeah, perfect fit. And since this is my favorite boring tool, I'll make something similar but bigger. So when I first started thinking about making this, I figured, oh, it's going to be pretty easy. But the more I look at this, it's actually got quite a few different machine surfaces in different alignments to each other. And that's not going to be that simple to do without about a zillion setups and different tools. The first thing we see here is the shank diameter is smaller than the stock must have been because this hangs out the edge. So although I'm making 25 millimeter diameter tooling, I'm going to start with a 30 millimeter slug of steel. And the second thing I'm seeing is that all these high quality boring bars, I think this was a Sandvik, rotate the insert, trading off a bit of clearance for a bit of rake. And it seems that angle's about 10 degrees. Mail time. Should be M3.5 taps. Damn, that marking's tiny. Does that read M3.5? Okay, so these are the inserts which I need. So this here is a DCMT 11T304, which I think stands for DC means it's diamond carbide, MT means that it's a mighty tough material, the 11 refers to some 11 millimeter included circle thing, the T3 means that it's thicker than 3 other inserts, and the 4 is how many seconds it's going to last when I start using it. No, that's not true. It means something completely different, but you can look that up yourself. Now for my homemade tooling, to be able to use this insert, I'm going to have to reproduce a pocket sort of like this. Those walls need to match the angle here, which I think is 7 degrees. It seems the easiest way to make them is to put a bit of a relief about the back of the pocket. You can probably drill that first, I'm guessing. The thread here is M3.5. I tried to get the smallest possible nose radius. These are 0.4 of a millimeter. Had I found them, I would have got the 0.2s, but this should work. So if I was going to make a boring bar manually, I'd probably just hack away at it until everything that was going to be in the way was no longer there. But trying to do this with a CNC actually requires a bit of forethought of how do we come up with all of these facets, these are angles. It's not actually that simple to plan it all, I think. Right, well that's the two ends cleaned up. I want to turn an eccentrically offset 25mm diameter here. So I need 5mm of total indicated run out. So I'm just about on 0. I think I'm slightly over, but that doesn't really matter. Yeah, I'm probably a couple of hundreds over the 5mm, but as I say, that doesn't really matter. That was probably not good the way I did that, because I now need to move the stock further out, and because there were no side loads on it cutting with the center cutter, I probably should have hung the stock right out of the chuck where it needs to be at the start, turned that center, and then not moved it again. Just drag that forward. I need to come out most of the way. Yeah, I wonder how round that center punch is going to turn. Worst case, I'll just make a new center in it, because that really wasn't that smart what I did. There's plenty of run out there. I slept on it, and I actually think I was overthinking a little bit, because when I took a closer look at the relief behind the insert on this one, it's just a cylindrical feature. So they didn't offset the boring bar. All they did was machine away bits of it afterwards. So I think I'll switch back to my 3-jaw and simplify this. Means I'll have to put an extra countersink into the end of this, leaving this as a scar, but hey. Okay, so that's not going to work. I need to get rid of that first. Maybe an end mill. Okay, a bit of run out, but I'll be turning that away anyway. To stop the pneumatic tailstock pressing the stock through the chuck jaws, I'll just put a little backstop in behind it. Just quickly whip that up. Right, quick touch up with a file, and it looks like this. That last pass was a bit too light. Should be a nice slip fit into the tool holder. Hundredth under, that's a nice fit. Right, now to machine the pointy end, I'm going to need some soft jaws. I've got some for the 4-jaw, but don't have any for the 3-jaws. Oh, wait a minute. That's not tight. I guess I was so busy sorting out the soft jaws that I never actually did the final tightening. Yep, tip's gone. Did I mention in a previous video that at the moment the Vendee Globe is underway? This is a solo, unassisted, non-stop round the world yacht race, right? These people are going to be at sea for 2.5 to 3 months. There's always been round the world yacht races. I remember as a kid, the Whitbread round the world used to be kind of a cool thing. Back in those days, there wasn't the telecommunications that we have today. Now, of course, each of these boats has got satellite communications on them, so we can follow them in quasi-real time. If you go on the Vendee Globe website, they've got this amazing tracker app where you can overlay the whole global oceans, winds, waves, clouds, you can see currents, and you can see all the boats, where they've come from, where they're going. This is so cool. There's one of the competitors who's half American, half New Zealander, and that's Conrad Colman. So he uploads to his YouTube vlog almost every day. At the moment he's in the middle of the South Atlantic. Can I ask you to please just follow the link below? Yes, so give some support to Conrad or any of the other of these mad sailors who are careening around in the Southern Ocean. They all certainly deserve it. Right, the next tool I need to make is going to be a D-bit. I only want something kind of small, just maybe 3 or 4 millimeters. I think these are all 6. But what about those? Ah, yeah. I was given a couple of pieces of like D-bit blank. Can't remember who gave them to me. Was that Christian from Switzerland, I think? Anyway, thanks very much. I'll grind up one of them. Yeah, 4mm stock, that's perfect. It's nice to have the point already split, so that takes away a lot of the grinding. So these are 4.2mm thick, which means that's the height that I need to relieve this to, or to taper it into. Right, so next I need to offset it 7 degrees. So that'll be 7.5, so we come back just a smidgen. It's about right. First up, I'll just rough in the taper. The next operation will be to grind in the primary relief angle, or cutting edge. I'll just blacken that edge a bit. I do want to keep my line for 4mm though, so I just won't colour it all in. Now in this setup, a D-bit grinder would be faster because they've got stops in the workhead to set the different angles. From here I want to rotate to 15 degrees and you'd have a stop for that. But I'll have to do that a different way. So what I do have is just one of these electronic angle gauge things. So if I zero that, and then hold it up against my D-bit if that works. If I can find the flat, like that. Okay, so that's about 0 there. Just throw on a witness mark. Right, now I can rotate that by about 15 degrees. That looks about right. Put another mark. Now from here on it's grinding the primary angle. I've since learnt that this is the wrong way to grind. Having the grinding wheel exit over the cutting edge makes for a weak cutting edge with chip out. Okay, so that's the primary cutting angle done. That's the lip that's going to do the cutting. Next thing, we need to relieve all of the back of this to give some clearance. So to grind the secondary clearance, I'll just be hand rotating it around like this, making sure I don't go past my 15 degree line, and just infeeding until I've got a nice clearance all around. You can see that back clearance is now thinned down my primary cutting angle, so it's only just a little thin line now, which is good. So next up, I just need to cut a little bit of clearance on the nose of the tool. Again, I'll give it 7 degrees. Set that about level and tilt it up 7 degrees to give a tiny little bit of back clearance there. Okay, that's not quite clear. Right, that should be it. You can see the primary cutting angle there, and also the slight angle on the nose of the thing to make sure it's got clearance in all directions. So hopefully that'll work. Right, moving over to the mill, I'm going to need to set up my tool holders. So this one's already set. So the second one, I'm going to need a 3mm end mill. Do I want a 2 flute or a 4 flute? I think I'll take the 4 flute. For that I need a collet holder. Oh wait, I need a second one for the D-bit. The last tool I'm going to need to set up is to do this back relief on the front and sides of the cutter. Luckily for that, I've got this end mill and it's tapered. So I'll be flipping the part over and cutting them with this one. So next up, I need to set all my tool offsets. Right, next I need to cut away the clearance and the pocket for the insert, but I think before I destroy my nice little blank here, I'll just use a bit of bar stock and try my milling toolpaths out on that first. Since it's got a rough surface, I'll just put a bit of copper behind it. Y0. Z0. And X0. Okay, tool number 2. And sure enough, it didn't just look terrible, it was terrible. Brand new 3mm end mill, lasted like 1 second. Right, since I've destroyed the only 3mm like normal end mill I've got, I've reposted my toolpath using just the single lip engraving cutter, and I'll try and do the whole thing with that. Cutting 0.5 millimeter per level, so it'll be 8 passes to go down the 4 millimeters. That head sounds awful. Right, I'm going to shut down for tonight and have a think about it. So it's now the next day. I slept on it and just run the head through the various speeds it's got, starting slow. Right, so I've gone up through all of the speeds, and as far as I can tell, it's only at the highest speed of 4,000 RPM that it starts rattling. I need to think about this. So in the meantime, let's switch over to the horizontal spindle. There are 2 lubrication points here on the head. This one is for Kluber grease to lubricate the bevel gears, and the second one lubricates the drill quill. Right, to convert the vertical mill into a horizontal mill, let's do vise on vise, shall we? When you switch over to a horizontal mill and use a spindle going this way, you really should reconfigure the whole machine, because kind of the standard is that the axis, which is parallel to the rotation of the spindle, should be Z. At least Linux CNC is expecting that. So things like tool length offset will always be set up to work with a Z axis. I've tried to create a second configuration in Linux CNC where I switch Y and Z and reverse the direction of one of them, but I'm getting errors and I'm not quite sure what I'm doing wrong, but in the meantime I'm just going to fake it. I guess one of the issues with using a mill as a horizontal is that the visibility is not that great to see the workpiece, but okay. You can see there's a bit of a whoopsie because I had my Z0 in the wrong height, so I had to restart the program with it 5 millimeters further up. So if you were wondering about the kind of crappy surface finish, well, that explains it. My home ground D-bit broke, or at least chipped really badly on its cutting edge. Bugger. I'll just check whether the rotation was in the right direction. Okay, now that's correct. Hey, does this look like a pretty weird failure to you as well? The chip's on the back side of the flute. So if I flip it over, this is the cutting edge. You can see its slight relief there. So that's the cutting corner. That's kind of intact with a bit of wear. But it was the back side that chipped off and broke off. Weird. I wonder if that was just because my diamond grinding wheel was a bit too coarse. But still, I find that bizarre. I guess having the main cutting edge and corner still pretty much intact is the reason why it got through the cut at all. From my initial setup, there's that first scar there. The pocket itself seems like it will probably be quite usable, and since that tool got worn out straight away, I'm going to have to do another test, I guess. So I think I might just leave that as it is and not bother finishing it. Yeah, so what am I going to do about this vertical head? The The thing that scares me most are the lower bearings, which are not normal bearings. They just run directly on the spindle. So if you have any corrosion or any problems on those, that's going to get expensive. Other than that, what else could cause a rattle? The gears, I mean, I've kept them well lubricated, but it's possible. The tool holder, the hydraulics to it, something along those lines. Anyone here got any experience with Maho milling machine heads? Yeah, any recommendations you have of what I should do to, troubleshoot this? I'd really appreciate it. And don't forget, after this video goes up, I've got a Patreon and members live stream. That's going to start on the hour. That's Central European time, 1 o'clock. Hope to see you there.